So just to make sure everybody is on the same page here, we had a quiz on Monday that most of you, actually I think all of you have now submitted that quiz. Let me double check. I've got it up on the other screen here. I believe all of you got that turned in here at the last time I looked, so of course that screen's not going to work. I got to flop it over here. So I'm still waiting on 2 of you for the quiz on Monday, and then a couple of you still are missing the quiz from Tuesday as well, so make sure you look into that, get that finished here soon, because there will be another quiz next Monday on this hip and valley stuff in the stairways. So let's finish this up. So let's look at a hip roof again. And let's look at the most difficult case that we have for a hip roof. It's an unconventional roof with 2 different slopes, and we're given the slopes rather than the setback. So I'm going to give you that this is a 30-foot span here. This up here is a 5/12 slope, and over here we're going to have an 8/12 slope. So remember, our first steps are to look at the common rafter. The first step is to find the height of that common rafter. We got 30-foot span, 5/12 slope. We are looking for this height here. So that's going to go off a run of 15 feet, half the span. So 5/12 equals blank over 15. And if we cross multiply and divide there, 5 times 15 is 75, divided by 12 is 6.25. That's 6.25 feet of height. The second step, really the important step then, is the step 2, to find the length of that common rafter. And of course, that'll be the square root of that run squared, 15 feet squared, plus the height squared, 6.25 squared. Now I'm going to double check my calculations here a little bit. The 6.25 was correct. We get 16.25 is the length of our common rafter. And I'm going to draw that in right here. So now, being an unconventional case and where we're given both slopes, there's an extra step put in here. And that is to find the setback. And we find that off of this longest jack. And from that longest jack, if I draw it, it's only going to be a one-sided triangle. This will be the longest jack. The one piece of information that we know about it is its height. It has to have the same height as the common rafter, 6.25 feet. This down here will be the setback. So we can use, and we know that the slope of that is 8/12. So now we know that 8/12 is our slope equals a rise of 6.25 feet over our setback here. So if we cross multiply and divide, 12 times 6.25 should be 75, divided by 8 is 9.375. This is 9.375 feet here. So that's our setback. Not always going to come out to be an even number of feet as we've had in many of our other examples. And that's just fine. We just adjust as we get towards the end. That last spacing on our jacks might be less than 2 feet because there isn't 2 feet left. Actually, sometimes it's a little bit more than 2 feet because the triangle formed is small enough we don't need an extra rafter in there at all. So anyway, now then we can proceed to the next step, which is going to be to find the length of that longest jack. Now that we have the setback, we know that's just going to be the square root of that setback, 9.375 squared, plus the height, 6.25 squared. Got that all crammed there, I'm sorry. So we calculate that. Square root, 9.375 squared, plus 6.25 squared, close, 11.267 feet. I'm going to label this here 11.267 feet. So now we can find the decrease on each side. Remember, being conventional, the decrease will be different on each side. So I'm going to start over here. Of course, we have to find the next longest jack in either case. Over here, I know that this dimension is 15 feet, just half the span. This dimension is going to be 13 feet, 2 feet less. We got 15 and 11.267 compared to 13, and I'll call that length x. So 15 goes to 13 as 11.267 goes to x, and we can cross multiply and divide. 13 times 11.267 divided by 15. Get 9.6 or 765. We're going to get a decrease there, 11.267 minus 9.765. Gives us 1.502 feet. So 0.502 times 12 is 6.024, so that's 1 foot, 6 inches. We'll take away the 6. And I'm guessing this comes out to like 0.3, yes, less than a 16th. So that is just 1 foot, 6 inches is the decrease on the hip side. That's the hip side decrease. On the main roof side, we have our common rafter, and we have the setback. Our next rafter will sit in there right here. We'll call that one Y, and this distance will be 7.375 because it's 2 feet less than the setback. So we've got 16.25 and 9.375. I call that Y, and this is 7.375. So I've got 9.375 is to 7.375 the same way 6.25 is to Y. So once again, we're going to cross multiply and divide. 7.375 times 16.25 divided by 9.375. 12.783. So again, we can get a decrease here. 16.25, I'm going to put the 0 in there, so we've got that to subtract. Minus 12.783. Borrow 410, this is 7. Borrow again, 14, this is 6. Borrow again, that's 11, this is 4. So 3.467. So that's 3 feet. 0.467 times 12 is 5 inches. Take off the 5 and multiply by 16. I'm guessing we're going to get about 10/16 or 5/8 of an inch. So this is the main roof decrease. So that was our hip rafter decreases. Remember, if we're a conventional where both slopes are the same, or in other words, if the setback is half of the span, that means the slopes have to be the same. There's only going to be one decrease. It'll be the same on both sides of that corner rafter. Remember, this is that hip corner rafter, or the hip rafter, some often called. And because the slopes are different here, the decrease is different on each side of it in this case. The same is true for a valley. I'm going to draw one of the simplest valleys I can here with an unconventional valley, at least. I'm going to have matching peaks. So this is, let's call this 36 feet over here for a span. Let's give it a 9/12 slope. And down here we'll give this 20-foot span. So once again, we start out with the common rafter. We know that since the spans are different and the peaks match, that this has to have different slopes. But either way, we need the height and the length of the common rafter to do anything else. So we're going to find this height here. Based off this run is going to be 18 feet. 9/12 equals blank out of 18. If we cross multiply and divide there, 9 times 18 divided by 12, was that 13.5, I believe? Yeah, so we get a height there of 13.5 feet. And again, we know that the important part of that is that common rafter length, which is going to be the square root of that 13.5 squared plus the run of 18 squared. Giving us 22.5 feet. We've had some really nice, easy numbers for our common rafter lengths on these two examples. So we're going to draw that in right here, 22.5 feet. Now, at this point, we could go ahead and find the decrease. We could find the next longest jack there, because we know this distance is going to be 10 feet. It's just half of this span over here. So then we would find the next one would be here at 8 feet. Call that y, and we could find it. So let's just go ahead and do that. $22.5 at 10 feet. Y at 8 feet, giving us 10 is to 8 as 22.5 is to y. Cross multiply and divide. 8 times 22.5 divided by 10 is 18 feet. So that means this is 18 feet here, so our decrease is 22.5 minus 18, which is just 4.5 feet, or 4 feet 6 inches on the main roof side. So there's one of our decreases already. Now, of course, we're going to have a different decrease on the L roof side over here. So let's take a look at the L roof. Remember, this is our L portion of the roof here. This is the main roof up here. On the L roof, we need to find the L common rafter, which is just the common rafter on the L roof side. And that's going to be this length right here that we're looking for. But it is actually a full triangle here. This is 20 feet. We do not know the slope, but we do know that this height is the same height. Since the peaks match here, it has to be the same height as our common rafter. of 13.5 feet. And since then this is on a run of 10 feet, we can find this length. Square root of 13.5 squared plus 10 squared. Giving us 16.800 feet. 16.800 feet here. So now our next rafter, we know that this setback here is half of this span. It's 18 feet. So we know that the next rafter there, right in here, this is going to be at 16 feet, and I'll call that one X. Let's draw that out. Got 18 feet here and 16.800 here. Next one, X, will be at 16 feet. So 18 relates to 16. 16.80 relates to X. Cross multiply and divide. 16.800 times 16 divided by 18. 14.933. So we subtract to get our decrease there. 16.800 minus 14.933. Subtracting there, we get 7, 6, 8, 1. So 1.867 feet, that's 1 foot. Take the 0.867 times 12, get 10 inches. Take off the 10, and then times 16. 6.4, so that's 6/16, or 3/8 of an inch. So our decreases. We have 4 foot 6 inches on the main roof side, 1 foot 10 3/8 inches on the L side. Well, quite a mouthful there just for that. The next step was stairways. So what we're going to look at here is, let's say we've got a floor thickness of 20 3/4 inches. A ceiling height in the lower level here, 98 1/2 inches. And I will give you a tread of 11 inches. I want to find two things. I want to find, one, the exact unit rise. In other words, the riser height. And two, I want the stair opening. Assuming I want 6'8" head clearance. So, remember, the first thing we need to find is the total rise. That's going to be the 98 1/2 plus the 20 3/4. Giving us 119 1/4 inch total rise. Next, and the number of rises. We're going to do that by taking the total rise, 119 1/4, divided by our estimated unit rise of 7 inches. 119.25 divided by 7 is going to give us 17.035. Now, I would be tempted, if I was building this for myself, to round that down to 17. That would, remember, if we round this number down, we get a riser that's going to be slightly larger than 7 inches. Well, that's so close to being 17 that it's going to be like 7 1/16 inch. I'd be okay with that. But remember, as a rule of thumb, we're going to round it up so that we stay below 7 inches. So we're going to have 18 rises. So then step 3 is to find the exact unit rise. In other words, the exact riser height. So we're going to take the total rise, the 119 1/4 again, divided by 18 rises. 119.25 divided by 18. 6.625. So I got to take off the 6 times 12 to make that inches. It's going to be 7.5 inches. Oops. 7.5. Oops, sorry, not times 12. Sorry. It's already in inches. I have to go times 16 to make it 16ths. That's 10/16 or 5/8. So 6 5/8 inches is what we end up as our exact unit rise. Each riser is going to be 6 5/8 inches. So right here. For a stair opening then, that's our first thing that we need. For stair opening, we first need to find the total required drop. Remember, that is just our floor thickness, in this case the 20 3/4 inch, plus our head clearance of 6'8". We're going to convert that 6'8" into 80 inches. So this ends up being 100 3/4 inches is our required drop. So that means we need to find our required number of rises. We're going to take that required drop, 100 3/4 inches, and divide by our exact unit rise, the 6 5/8. $100.75. Throw that out. 100.75 divided by 6.625. That's my 5/8. At 15.2. And this, of course, is always round up. So we need 16 rises. The number of runs then is always 1 less than the number of rises. So 16 minus 1 is 15 runs. In other words, 15 treads. So the stair opening is the number of treads, 15, times the size of the tread, 11 inches. That's 165 inches. And let's convert that into feet, inches, and 16. So 165 divided by 12 is 13.75. So that's 13 feet. Subtract the 13 times 12 gives us back 9 inches. So to make that stair opening work, we need a stair opening of 13 feet 9 inches for that staircase. Those are the 3 processes that are going to be on your quiz on Monday. It's already posted out there in the week 4 folder. If any of you would like to work ahead and do it and just get it done, please feel free. Otherwise, it'll be assigned on Monday, due for Tuesday. So today we want to take these stair openings to the next step. We want to talk about a landing in our stair opening. Minimum landing, depending on what you're working with, and what area you're working with, what type of building. If you're in a residential building, minimum landing is 36 by 36. If it is a commercial building, a minimum landing is 36 by 60. We're going to go just strictly residential here. So we're going to have a landing here in the corner, 36 inches by 36 inches. Put this on again. And we're going to come into our staircase from this side. And here's what we have. We have coming into this, now let's say we have 108 inches of space to work with. We want to know, if we do a side view here, this is our landing. There's our landing. We want to know how many stairs are going to go up this way, and then how many stairs are going to have to be down below here. Come off that landing. So the first thing we're going to do here is determine our tread size, which is going to be 10 3/4 inches. I'm going with that just to change things up a little bit. What we're going to do is actually we're going to adjust the tread size based on what's the available space up above. So right now we need the available space 4 stairs above the landing. That's this distance here, which is going to be 108 minus the 36. Which is 72 inches. Well, with that in mind, 10 3/4 inches, 11 inches, none of them are going to make much of a difference because nothing's going to come out really well on 72. 10 3/4 is still only going to give us 6 treads. It won't quite give us 7 treads. We could get 7 treads if we did like 10 1/4 inches. I don't want to get that, well, I guess we probably could, but I'm not going to get that small here. So we're going to keep it at 10 3/4 inches. So the actual size up there, we're going to do our 72 inches divided by our desired 10 3/4 inch tread. Is 6.69. So that means we only get 6. This has to be rounded down because if we round up, we're going to go past here, and we can't do that. We're restricted to that 108 inch space. So we're only going to use 6 treads, which means the distance is going to be 6 treads times that 10 3/4 inches, which is going to be 64.5, I believe, inches. So the actual distance from bottom of the stairs to the top of our stairs, or from the last step at the bottom of the landing to the top, I should say, this is going to be 64.5 inches, 64.5 inches. So we're actually going to be coming up 7.5 inches short of what our restriction, so it'll give us a little bit extra space up there. So now we had 6 treads up above, which means, remember, we always get 1 extra riser. That means we had 7 rises. Now we need to figure out what is our actual unit rise. This is going to work exactly the same as what we did before. Let's say we have a floor thickness here of 14.5 inches and a ceiling height of 94.5 inches. That's going to give us a total rise 109 inches. We're going to do 109 divided by 7. 7 is our estimated height. give us 15.57 rises. Rises get rounded up, so we're going to use 16 rises. So the actual unit rise will be the 109, the total rise again, divided by 16, which is that, what is it, 6 and 13/16, I believe. Subtract the 6 times 16, it is 13/16. So 6 and 13/16 inches is that actual unit rise. So that means the drop for those 7 rises, or drop above the landing, is going to be that 6 and 13/16 times the 7 rises. 6 and 13/16 from 7 is going to be 47.6875. So then that means the drop below the landing is our 109 inches minus the 47.6875, which is going to be 61.3125 inches. We're going to divide that by our 6 and 13/16 to find that we still need 9 rises. So we need 9 rises below the landing to get down to the floor. This tells us the riser, the height of the landing. Is at 61.3125 inches off the lower level floor. Now we need stair opening. The stair opening in this case is going to be how far do we have to go in this direction. We know this has to be all open, but how far do we go over here before we can cut off this opening here? Well, our total required drop for the stair opening is going to be the 6 foot 8 inches of head clearance plus our floor thickness, which was 14.5. Over 6 foot 8 is 80 inches plus 14.5, that's 94.5 inches of drop. We find the number of rises, 94.5 divided by that 6 and 13/16 again. 94.5 divided by 6 and 13/16. We get 13.87. So that rounds up to 14 rises. Well, above the stairs, we had 7 rises. That means below the stairs, 14 minus 7, we need, or above the landing, I should say, we already had 7 rises. Below the landing, we need 7 more rises. 7 rises, of course, turns into 6 treads. 6 times our 10 3/4 inches is 64 1/2 inch. So this distance here that we need to go is 64 1/2 inches, or 5 feet 4 1/2 inches. That the stair opening has to go around the corner. Any questions there? Now, admit this is extra. I'm not going to, this is not something I'm going to quiz you on, doing a landing and turning. But in the shop, you guys will do a mock-up of a stairway with a landing in it. You'll need to be able to figure out, at the very least, you won't do the stair opening because you won't be doing a floor system above it, but you will at the very least have to figure out what that exact riser height has to be and all that. And of course, your 36 by 36 landing is going to be made much bigger than that. Most of the time, what you do is you make them 36 by 48. The 48 goes in the direction of what the top piece is going to be. So that top stair, the first step of the top staircase sits on the landing, and you can go up from there. Because that bottom step has to sit on something. So you elongate the landing to make room for that. Okay, so with that, you guys do have a half hour of class left here today. What I'm going to do is, remember, those of you, let me get back to my assignment list here. You have quiz. Let's see, all but 2 of you have turned this one in, but you got quiz 130B from Monday to turn in. Make sure you've got that completed. Quiz 2-1 from Tuesday needs to be completed. A couple of you still needed that one. And then on Monday, it won't even be assigned. It's not due till Tuesday. But you just will get a start on it now if you get a chance, because we just reviewed all the stuff and we won't be going over it again. Quiz 2-4 will be due on February 9th. That'll be next Tuesday. And then homework. There's 3 worksheets sitting out there. You have the hip roof worksheet from Monday that should be done. The valley worksheet from Tuesday, and the stair worksheet from Tuesday. So if any of those are not done, make sure you finish those up. And then for today, there's a complex stairs worksheet out there. And this is stairs with landings in them. So I call it complex, but it actually does take you a little bit step by step. So it might help you out if you're struggling with the stairways a little bit. It helps remind you of the steps. Anybody have any questions on all of that mess? Okay, so what I'm going to do is I'm going to give you guys your last half hour here to work on stuff. I don't want to do anything new because I feel like we have covered a ton of material this week. Next week, we're going to go back into that truss packet. That's the one that has the measurement on front of it, and I will repost it for us. But we're going to start finding missing dimensions on trusses on Monday. Hopefully we'll get through that packet in a couple of days. Maybe not next week, but either by the end of next week or early. In week 5, we'll be doing our Unit 1 test and then moving on from there. Okay, so I'll let you guys work. I'll be on the network here if you have any questions.